Folks. So the last time we were here, we were talking about the different withdrawal symptoms of drugs. And as I talked about, many of the withdrawal symptoms are going to be the opposite effects of the drug itself. Now, let's take a look at two different types of opioids, morphine and methadone. So morphine or heroin or other drugs like it may be administered with IV. Now, in this particular case, heroin is applied intravenously, which means it's very fast acting. And as you can see, when the drug is faster acting, the effect is going to be particularly intense. Compare that to something like methadone, which is often used as a rehabilitative treatment. Notice that the effect of the drug, because methadone is taken orally, lasts for a really long period of time, up to 32 hours. But because it's longer lasting, it has less of an intense effect. Now let's take that same idea and apply it to withdrawal. Heroin has a very intense drug effect because it's so fast acting, and as such, its withdrawal symptoms are short, but they're also incredibly unpleasant. And they're much more intense than you'll see for something like methadone. Methadone is longer lasting. The withdrawal symptoms will last for a longer period of time, but they are considerably milder than heroin ever is. So, what do we do when we're dealing with withdrawal? Generally, you should not go cold turkey. Generally, your goal is detoxification. This is basically the point when the withdrawal symptoms end. And what we know is that if opioids are readministered before the point of detoxification, that will get rid of the withdrawal symptoms. But it also means that you are going to continue with that physical dependence. It also leads to a cross dependence with other opioids. So, like I said, if you get hooked on heroin, you can also develop a dependence on things like Oxycontin. And if you have a bad cough, codeine in your cough syrup is not going to work for you the way it would somebody who is not addicted to an opioid. Additionally, readministering an opioid before the point of detoxification will stop and reduce withdrawal symptoms. You want to make sure if you really want to stop taking opioids that you get to detoxification. And that's a very powerful obstacle. You can actually have dependence without addiction. So there was this older idea that even if you weren't addicted, you could still eat, that you had to be dependent on a drug to actually be addicted. But one of the things that we find is that many people who are suffering from chronic pain will take opioids, and they certainly won't take them to the point where they are addicted. But oftentimes, these chronic pain patients will eventually show signs of tolerance and dependence. So, what will end up happening is that their pain may continue to get worse even as they take more of a drug, and they may feel that they have to take more of a drug to stop that pain. Now, one of the things that we are always careful about, especially with chronic pain, is paying careful attention to the dosage. Ideally, you want that dosage reduced over time. You do not want somebody to stay on this longer than they need to be to the point where they're developing tolerance and needing a higher dosage. Generally, when you do this, withdrawal symptoms and drug abuse is a lot less likely to happen. Now, what other parts of the brain are involved in withdrawal symptoms? So, one of the things that we've done, we can apply opioid antagonists that are designed to block opioids to the brains of animals that are actually dependent upon these opioids. And in general, we found that the locus coeruleus and the periaqueductal gray does seem pretty sensitive to that. In addition, the nucleus accumbens seems to be really critical for the aversive, the negative effects, and the negative emotion. Additionally, some of the motivational aspects of withdrawal, the wanting to find something. Now, one of the things that's kind of interesting is that for a lot of animals that are dependent upon opioids, they will typically seek novelty. So rats will generally tend to want to look or look at new places or try new locations, they generally don't revisit the same location over and over. So they're very highly motivated. What's actually kind of interesting is that when you apply an opioid antagonist and mimic withdrawal symptoms, these rats will develop a novelty aversion. So they will not want to go to new places. They will not seek out new locations. They will tend to stay in the locations that they're familiar with. And that's sometimes taken as an index of lack of motivation. And I want to talk about one particular theory relating to drug addiction, particularly with heroin and other opioids, that was developed by Himmels Bock. Now, Himmels Bock basically says that the goal of any living being is homeostasis, a particular sense of balance. The cellular mechanisms, all of the physiological mechanisms, they all want to be in balance. When you take a drug, that introduces a particular disturbance. So the presence of drugs disturbs that balance. So because your system seeks homeostasis, your brain and the rest and your nervous system will basically develop compensatory mechanisms that counteract the effect of the drug. And that may potentially lead to tolerance because you're developing all of these ways to compensate for this disturbance that has entered your body. Now, we'll find that you get back to that homeostasis until the drug is removed. You've still got those compensatory mechanisms going, but you no longer have the drug. So the adaptation will continue because it tends to be a little bit slower acting, and we will often see a rebound. So when I mentioned that some of these cellular mechanisms overshoot, this is exactly what I meant, because now you no longer have the drug, but the compensatory mechanisms are slower to act, so we once again get a disturbed homeostasis. So what evidence do we have for this particular model? So what you're looking at here is some data for animals that received a morphine treatment. So here we have what the rats were like normally, and in this particular case, we are looking at inhibition of adenyl cyclase. That is a secondary messenger that makes cyclic AMP, which is involved in a variety of different cellular effects. So here is our normal homeostasis, and then we begin the morphine treatment. And you can see up to that point, cyclic AMP is at a baseline level. Now at this point, we introduce the morphine treatment and almost immediately we see a decline in cyclic AMP. Remember that, remember in this case that because opioids are depressants, they will depress cellular function. And so in this case, we see a reduction in cyclic AMP. And then after 2 days, after developing a tolerance, we return to that homeostasis. The compensatory mechanisms are working to counteract these acute effects of morphine. So we return to baseline. At that point, we withdraw the morphine, we create a period of abstinence, and what we can actually see is the effect of those compensatory mechanisms. In this particular case, you can see that the cyclic AMP production overshoots almost to 400% of its original production. So it's doing 4 times as much as it was before in this case. And as a result, we get this overshoot. We will have a withdrawal phase with which cyclic AMP will start to drop. And then finally, with detoxification, the system will return to normal. You can kind of see what happens when the compensatory mechanisms kick in after a disturbance has been introduced. And when that disturbance is removed, we also again have a temporary imbalance. We have to get back to our homeostasis. Now, conditioning will also play a role here. Generally, what we're going to find is that if you repeatedly administer a drug in a given environment, oftentimes we will begin to anticipate the effect of the drug itself. So what's really interesting is that after a while, just going into that environment can create some of the anticipatory physiological effects in animals. Animals will start developing some of the symptoms of being on opioids long before they're ever injected because of the associations that they've made with this particular environment. Now, generally, one of the things that we find is that this is also true with humans as well. It is not uncommon to watch heroin users or oxy users end up taking a drug in a particular environment, and they will develop a tolerance. But what's really important is that this tolerance is associated with a particular environment. So, what will often end up happening is that should these people go to a new environment, even if they're taking the same amount of a drug that they would before, they're in a new place and they don't have that tolerance. And so, oftentimes, what we will find is that for people who are addicted and they take a drug in a new environment or a new place, they can potentially overdose and die. And part of the other thing that we will see is that conditioning also plays a role by providing. So we already know that opioids are incredibly reinforcing, but there's also secondary reinforcing in the environment. The social groups that you hang out with. If you like being around these people, that will make you feel good and want you to engage in it more. The injection ritual itself can serve as a secondary reinforcement for the primary reinforcement that is about to come. Now, if we look at a PET scan of these drug users, what we will tend to find, now we're looking here at people who are addicted to cocaine. We will tend to find that in this particular case, we will see activation in both the amygdala and the anterior cingulate cortex. These areas are really critical for emotional memories, and they also help us form expectations. So, what you're looking at here are people who are addicted to cocaine, and they're either watching a nature video or they're watching a video of somebody preparing to take cocaine. Now, in both of these cases, you can see heightened activation in areas like the amygdala as well as the anterior cingulate cortex. Both of these areas have strong connections to the nucleus accumbens. And what we tend to find is that cues like watching a video of someone preparing and taking cocaine can actually act as a primer. It will help increase the likelihood of craving and drug seeking behavior. So I'm going to stop here because we are going to continue with a discussion of treatment for opioid abuse. I'll see you then.